Hello, everyone. Good morning to you in Australia. Good morning in New Zealand. And if you're joining us from any other country around the world, it may be good afternoon or good evening, but we're certainly happy to have you here and participating with us in this webinar. Our webinar today is titled Why Direct Georeferencing is Essential for Profitable UAV Surveying and Mapping Missions. So we're going to be discussing this and kind of presenting a business case on this. My name is Brad Schmidt. I'm the Global UAV Sales Manager here at Applanix. I've been in the geospatial industry for just over 30 years now, and really happy to be participating in the UAV side of the business, since there's a lot of exciting things happening with the UAV market, not just in Australia and New Zealand, but around the world. I'm joined today by Naush Lada, who's our Sales and Channel Manager for Australia, New Zealand, and quite a number of other countries around the world, but certainly part of taking care of Southeast Asia, Oceania area, etc. And we're also very happy to have Peter Terrett with us. Peter is the Managing Director of our distributor in Australia and for New Zealand, 4D Global. So Peter is with us as well, and we're really happy to be able to present this webinar to you today. So let me just go through some of the webinar logistics that we have. So this presentation will take probably a little bit better than 30 minutes, probably about 30 to 40 minutes for the presentation. And then we've allotted about 15 minutes for questions. So we will try to get through all of your questions. And if you do have questions that come up during the webinar presentation, please enter them in the chat box and we'll get to them at the end of the webinar. So we'll get to all of your questions. But it's certainly helpful that if you see something that you want to ask a question about, please enter it into the chat box and just record that while it's still fresh in your memory. The webinar will be recorded and we will circulate this to all attendees after the webinar. The attendees will be muted during the course of this presentation. And as I say, if you have questions, please enter those in the chat window. So who's this webinar directed to? Well, really it's kind of focusing on those who are working with payload and or who are payload and sensor manufacturers or UAV manufacturers or integration specialists. We also work with service providers who are providing services to the markets that they're currently working in. And we can talk a little bit more about how we support each of these industries. And I'll say a few words about that as we go through our presentation today. So our agenda, we'll take a look at UAV survey and mapping in Australia. We're going to talk about georeferencing UAV survey and mapping data. We're going to talk about how does Applanix direct georeferencing work. That's really the core and very much germane to what we're doing today. We're going to talk about saving time and money with Applanix DG, and we're going to talk about some application scenarios. Where is DG essential in terms of being able to use this technology? In other words, where is it indispensable? And then we'll do a Q&A and wrap up after that. Okay, so a little bit about Applanix. So Applanix is basically a spin-off from Honeywell Canada that happened in 1991. And that spin-off was designed to allow us to kind of focus on GNSS-aided inertial navigation for the land, marine, and airborne industry. We've actually proven this technology out that we're going to talk about today over many years in our manned airborne business. Basically, the technology of direct georeferencing is just refactored from that manned airborne business, and it basically has been miniaturized, if you will, to meet the size, weight, and power requirements for surveying and mapping on UAV platforms. We're headquartered in Toronto, Canada, and we were part of, or we were acquired by Trimble in 2003. And that has been a really excellent acquisition for both Trimble and for Applanix, because we brought these technologies together. We brought the excellent technologies that Trimble offers with their GNSS systems, the global navigation satellite system support that they have. They're world leaders. Trimble is a world leader in this area, and certainly Applanix is a a world leader in the inertial navigation segment. So we've taken these technologies and we've combined them together, and that really has provided us a really good basis for developing solutions, positioning solutions for both the land, marine, and airborne mapping. 4D Global was also established in 1991. So you're looking at a couple of well-established and entrenched companies in the geospatial market. 4D Global specializes in sales, consulting, and product development, as well as training in the geospatial industry. They are our representative in both New Zealand and Australia for the technologies that Applanix brings to the market. The head office is in Melbourne, and they've been an Applanix reseller since 2018. So we're really happy to be working with 4D Global, and are really happy to have Peter here today to be with us as part of this. So let's start into the presentation. I like to start my presentations with a quote, and this one I feel is very germane and relevant to what we're going to talk about today. So let me just take a second and read this. It says, "The impact drones are having in the survey and mapping sector is arguably more significant than anywhere else. Experts have identified the survey and mapping industry as the most profitable of all segments, while users have been able to quantify the value of the technology related to enabling a potential 90% in time savings and an increase in safety." And this comes from the Commercial UAV News, which is part of the Commercial UAV organization that basically just hosted a conference just this past week. So I find this this particular quote very encouraging, because it really shows that the technology and the relevance of the technology to surveying and mapping, and UAV surveying and mapping in general, is very relevant to this industry. So let's take a look at Australia. So why does Australia have a thriving drone industry? Well, it does, and there's a number of key reasons for that I have displayed here on the screen. First of all, there's very good drone-related research happening in Australia, so that gives it a strong basis for developing the technology in Australia. Land and coastline availability, it's kind of like Canada, where we're based. A large land mass, lots of mapping possibilities, lots of things to be mapped, and UAVs just seem to really fit into that really nicely. There's a strong aerospace manufacturing base in Australia. There's drone-friendly laws, so it makes it a little bit easier to fly your drone in a professional, I guess, in terms of even a recreational sense as well. And there's great proximity to growth markets. Basically, in the industry, there's a lot of discussion around the Southeast Asian market really growing rapidly in terms of drones and deployment of drones for all kinds of different applications. That really sets Australia up nicely to be able to service that market. And it's home to global companies and industry stakeholders. So a lot of great things happening in Australia, and obviously good reasons to develop business within your country. Okay, next, I would like to talk a little bit about georeferencing UAV surveying and mapping data. So what we're really here to talk about today is direct georeferencing. So what is direct georeferencing? Well, there's a lot of different methodologies to georeference UAV and airborne data. We're going to talk about some of these a little bit later on, but I just want to give you a background in terms of what direct georeferencing is. So if you're basically flying your UAV and you have a sensor payload, if you're able to basically capture positioning information using an onboard GNSS system, basically a GPS system on board, as well as orientation data through an inertial system that would come through an IMU, an inertial measurement unit. And if you've calibrated your sensors and you've accounted for lever arm angles, etc., that's like the distance between the antenna and the sensor payload, etc., you actually have all of the mathematics in place to take this data and put it on the ground exactly where it needs to be without the need for ground control points. This is a huge time and cost savings if you do not have to capture ground control points. And you can do that. As I say, that's because nothing is estimated. There are no extrapolated values here. Everything is measured in. It's all measurements, it's all mathematics, and we have the mathematical equations to put the data on the ground where it needs to be. So why is this important? Well, it's important for two reasons. It's important for precision and it's important for accuracy. Now, precision, if you take a look at the target in the middle, precision basically refers to, and if, say for example, if these were arrows, the clustering of those arrows. So if you can get all of your points well clustered together, that means you have high precision. Accuracy is about taking that cluster of arrows and put it right in the center of the target. And if you do that, then basically you have the best of both worlds. Not only are you precise, but you're also accurate. And that is what Applanix is all about. We're all about accuracy and precision with respect to positioning of data. Now let's take a look at that in the context of a LiDAR sensor. So if we're flying a LiDAR over a building, this would be what things would look like. So for example, down in the lower left-hand corner, if you're not accurate and you're not precise, your points are going to be all over the place. If you have accuracy, you're going to be able to get the points in the right location, but not precise. They're not lined up the way they should be. And of course, precision gets all of your points lined up, but they're not basically located where they need to be. And if you have both accuracy and precision, in this case, you have the best of both worlds. You basically have all of your points lining up in the position and with the accuracy that they need to really be. So that's why it's so important. And that's what we focus on at Applanix. So I said we talk a little bit about methods of georeferencing, and I've got three of the most common methods that you'll find in the industry today. The first is something called aerial triangulation. Now, aerial triangulation has been around for many, many years. It's tried, tested, and true. It works. But the thing with aerial triangulation is that it's dependent upon ground control points. And if you're flying cameras, it's dependent upon having significant overlap of your flight lines, as you can see in the image on the left-hand side. So it's great. You can get really accurate results using aerial triangulation. But if you're working in an area where you need to lay down those ground control points, that's going to take time and money to be able to do that. If we can eliminate that process, we can actually offer a cost savings, which is an advantage if you're basically offering services to the to whatever industry. It could be construction or many, many different types of industries. Next, we have what's called PPK or RTK, PPK post-processing kinematic. PPK uses a GNSS, so it captures positional information, but it still needs some ground control points to basically help tie that imagery down, and you still need to have a high degree of overlap in order to process that imagery correctly. So PPK or RTK is basically an advantage over aerial triangulation in terms of a cost savings, but it's not the end of or necessarily what we can achieve ultimately. If we take that a step further and we add an IMU or an inertial system to the PPK, now we can have a different result. We can actually see that we can reduce the number of flight lines that we need, and we don't need, in fact, we don't need any ground control points. We'll just have one that we would use as a checkpoint, just to validate our results and make sure that everything is correct. So really, direct georeferencing represents the progress of development in the industry, moving from aerial triangulation to RTK or PPK, and now to direct georeferencing. Okay, and I did want to mention a little bit about georeferencing and LiDAR, because basically there's so many organizations out there that have adopted LiDAR these days. It's really getting a lot of attention. So I just wanted to basically say that in addition to working with radars and cameras and multispectral scanners, etc., we also work with, our direct georeferencing works very nicely with LiDARs. And the reason here is that each of the LiDAR points is assigned a position and orientation value that allows us to complete that, that direct georeferencing process. The issue with using other methodologies is that they're much less accurate than using these GNSS integrated with inertial systems, because you tend to either register your LiDAR point clouds to existing data sets, or you somehow interpolate the data to get it into its correct location. Whereas with direct georeferencing, again, everything is measured in and everything is accurate on the ground. Okay, a little bit more about how DG works and kind of what you need to do surveying and mapping using a direct georeferencing system. So the first thing you would need would be a UAV that is enabled with direct georeferencing, and that's really the integration of a GNSS inertial system, a board set on board your UAV. And basically, I'll talk a little bit more about what those different configurations are. But essentially, you would have a system that would be recording both positional and orientation value associated with the sensor payload that you have on that platform. Now, you also need that the GNSS portion of the system will get you down to about 1 meter of accuracy. But if you want to basically take that down to a couple of centimeters of accuracy or better, you're going to need some sort of an augmentation system. And so we offer 3 different augmentation solutions. And I'll talk a little bit more about this later on. But the first one that I have highlighted here is something called Smart Target. Essentially what it is an aerial target with a GPS receiver in the center. So this is what we use to basically collect our ground control point. And it's in constant communication with the various constellation of GNSS satellites. This is a very, very simple system to operate. You simply put it down somewhere in the field. You can turn it on. It starts data logging right away. It's independent of flying your UAV, but the information that it collects is the necessary correction data that you need to get down to that centimeter level of accuracy. So essentially you have your augmentation solution, your direct georeferencing solution on board your UAV platform, and that's really all you need in terms of being able to go out and use direct georeferencing in the field and fly your missions. After the mission is over, we process that data through a post-processing solution called POSPAC. POSPAC UAV takes that orientation data, the positioning data, the data from the GNSS target or the receiver, along with the imagery data, and it processes it automatically through POSPAC. Now, because we're not basically using a process like aerial triangulation where you're physically matching a point on a ground with a surveyed in GPS point on the ground with a corresponding point in the image, you can save a lot of time. Basically, because it's all mathematics, the processing is very, very quickly, and it performed very, very quickly. And what results out of that is a couple of different types of files. So if we're working with imagery like multispectral imagery or camera photography, we'll get an EO file coming out of that, or we'll get an SBET file, a smooth best estimate trajectory file that can be taken into any number of products out there that basically generate your information products. And we can even generate, in the case of point clouds, we can generate a LAS file as well and have that available. So the output of the direct georeferencing coming out of POSPAC UAV are input files that you would take into a third-party application for creating information products, or you could take it into our own product as well. So we have a product called UAS Master that will take the output of the data from POSPAC and take it into an application that you can generate information products. Okay, let's take a little bit of a look at configuration. So this is a situation, in this case, we have a micro drones UAV. We have a Sony, I think that this is, what is this, the RX1 camera, whatever. Anyways, we have a Sony camera here, and we support all kinds of different Sony cameras or any other camera. It could be a Phase 1 or Luminera, it could be any kind of camera. So that's basically mounted, in this case, on a gimbal underneath the UAV, and we're gonna basically integrate that with with one of our APX systems, and I'm going to talk about these in just a moment. But what makes these unique is that this is an integrated GNSS system with an IMU on board that has been specially calibrated for surveying and mapping. We don't serve in the UAV business segment. We don't serve other industries. We serve basically the UAV survey and mapping industry. So we're all about precision and accuracy, and that's what we strive for at Applanix. And then on top of the UAV, we have an antenna that basically communicates, as I showed in the previous image, with the GNSS constellations out there. So we can support up to 336 channels with this APX receiver right here. So that's what the configuration would look like. And now it is a bit tricky, well, not tricky, but it takes some engineering work to actually get this board integrated onto your UAV sensor payload. But the great thing is that we've done this many times before. We have manuals that support this, and our engineers will also support any kind of integration work you tend to take on. So we can actually reduce that, make it a little bit easier for you to get that integrated into your system. And this is just a picture where we've integrated one of our APX boards into along with a phase 1 camera system. And so we've got the whole thing properly integrated here on this particular platform. And I did want to mention LiDAR as well. In this case here, I'm showing a smart drone UAV platform with the LiDAR. This is an Oster LiDAR out the front with an antenna on top, and again, an APX-15 integrated with the LiDAR system. And that allows us to get very, very accurate LiDAR data. So that's what the configurations look like. These are the board sets that we offer right here. So we offer 4 versions of our APX systems. So the first one is our flagship product, something called the APX-15 UAV. We've been talking a little bit about this, and this is our standard board. So if you're basically flying a UAV with a sensor payload that is fixed to the UAV platform itself, then the APX-15 UAV would be the right product for you. We have some different versions of that as well. So we have something called the APX-15 external IMU version. So this is the same as the APX-15, except we offer a second IMU that basically is supported or used to support the sensor payload on a gimbal system. So the main board here that you see in the picture would go on the UAV airframe, and the second IMU, the little board, would go on a sensor payload. In this case, what you're doing is you're collecting 2 sets of orientation data, and you need that because the UAV may be moving in one direction, whereas your sensor payload is continually being oriented to the nadir. And so, you need that second set of orientation values to properly process the data when you're using a gimbal. And the POSPAC software does process indeed both sets of orientation values along with the positioning data that is collected by the GNSS. Looking now at the lower left-hand corner, we have something called the APX-18 UAV. This basically features 2 antennas. You can see a couple of connectors here right at the top end of the board set. And this is where you connect in the antennas. Now, and this particular board set is geared towards static or slow-moving UAVs. So that might be in a case where you're surveying infrastructure, maybe a bridge or a tower, or maybe you're actually even just hovering and taking pictures of various components, maybe on a cell tower or on a windmill or something of that nature. When you're standing still, basically, your IMU is not collecting any data, because it's basically waiting for motion before it starts collecting data. So therefore, by adding the second antenna, we can actually control the trajectory much better and still get very, very accurate data. And then finally here, we have our high-end system, something called the APX-20 UAV. And it's high-end because we basically use one of these IMUs. In fact, these are the same kind of IMUs we use in our manned airborne side of the business. Now, this IMU is a little bit bigger, a little bit heavier. It would typically go on the UAV mainframe itself, and we'd put the board set on the sensor payload. So this is a dual IMU system as well too. And the good news is we've actually released a new version of this IMU, and it's actually about 1/3 of the size and a lot lighter than this with the same performance. So that's, in fact, I'm not even sure if that announcement has been made yet. It's going to be made sometime in September. So maybe I'm jumping the gun and giving you a little bit of advance notice of this, but anyways, there it is. So you can look forward to or look to seeing a new lighter IMU, a smaller, lighter, smaller IMU with our APX20 board. I did mention we're going to just talk a little bit more about augmentation solutions. So these are the correction systems that you need to get your data from, you know, a meter down to about a couple of centimeters. Now, what is typically used in the UAV survey and mapping industry are physical base stations, such as the one we have pictured here, or you could use any other Trimble base station or any other base station as long as it can deliver a Rhinox file. So that is perhaps the most common form of base station that you'll see in the UAV surveying and mapping industry. Now, also, what is emerging in the industry is the use of virtual reference solutions. So we have two on offer at Planix. The first one is called SmartBase. So this basically uses local core system. So you can actually fly your UAV mission without having a physical base station and basically use the reference, the virtual reference solution or system to get an accurate result for correcting the data. And you can find more of this. We have a separate website for the Planix SmartBase. If you Google the Planix SmartBase, you'll find that information. Now, we also have something from Trimble called Trimble RTX. And we actually use the RTX solution in a post-process mode. So post-processed RTX or center port RTX. And what this is that Trimble has established receiving stations that receive GNSS data 24 hours a day, 24/7, 365 days of the year. And we continue to expand out that network. Now, right now, the RTX system takes about 30 minutes to converge or to initialize. So that may be a little bit in places like Australia and New Zealand, maybe that's not pragmatic to use that, but we are implementing what's called fast regions. These are really densified networks of the RTX receiving centers. And basically with fast regions, anything within a fast region, we can converge within about 5 minutes, which is perfect for UAV surveying and mapping. So right now, the fast regions are in all of the US and parts of Canada, mainly the southern areas of Canada and most of Europe. But we're expanding this on an ongoing basis. So, you know, just keep your eyes open for new information about RTX. If you want to learn more about this, there's information on our website at planix.com, but also Trimble has quite a bit of information as it is their system. Well, we're part of Trimble, it's our system, but in that particular business unit, they have a lot of information regarding the PPRTX solution that we offer. And then the third component I talked about was something called POSPAC. And so POSPAC is our back office software, post-processing software. It comes in a couple of versions. We have POSPAC UAV, which is basically a subset of POSPAC MMS. POSPAC MMS serves all of our positioning industries, so land, marine, manned airborne, UAV as well. But we've actually created a special subset of POSPAC MMS called POSPAC UAV specifically for the UAV industry. And as you can imagine, it is cheaper. It's quite a bit cheaper than POSPAC MMS, but it is just focused on the UAV segment. And the way that works, and I'll kind of explain this again, is that you take your GNSS data, your inertial data, your base station data, and your imagery, and you run that through POSPAC UAV, and you get your output products that then allow you to take that into any number of different third-party packages, or you could use Trimble's own UAS master for this as well. And it is modular. We have some modules that fit on top of POSPAC UAV, designed for camera calibration and a few other things. that we offer. So that's the POSPAC software. We have got a lot of great information on our website about POSPAC. I did want to mention something fairly new that we've introduced, and it's basically DG, or direct georeferencing as a service. So what we do is we offer the same board as hardware as a service, and we offer the POSPAC cloud software. Now, basically, this particular solution is sold through our OEM partners. So our OEM partners will basically provide these systems to end users for use. And if you want to check a couple of our OEM partners that are using direct georeferencing as a service, I can refer you to Microdrones, microdrones.com. Or if you take a look at GeoQ Group, I think it's geoq.com, also offers direct georeferencing as a service. And so you get, essentially you get, in both cases, you can actually rent, essentially lease or subscribe to a complete system for surveying and mapping from UAV platforms. One of the key advantages here is that if you're, just want to try out a system or just want to see if this is particularly useful to the business that you're in, you can actually subscribe to these systems, try them out for a lot less cost than it would be to physically implement the systems yourself. And so that is a big advantage. We're starting to see more and more of this in the industry, but we've been certainly, I think, one of the first, maybe even the first, to come out with a direct georeferencing as a service offering for the UAV industry. So very, very interesting. Again, another model in terms of how you can get into the industry and check out the technology. So just a little bit more about DG as a service. So this, as I mentioned, is directed towards our OEM partners. So we consider OEMs as being UAV manufacturers or sensor manufacturers or UAV systems integrators. We do work with service providers, but you have to keep in mind that if you want to integrate our technology as a service provider, you're going to need some engineering support in your company to be able to do that. But if you want to work with us, we're certainly happy to work with you in that mode, and we'll certainly help you get it all set up. So as I said, our DG as a service is comprised of hardware, the same hardware that we provide or sell as perpetual boards, or basically purchased board sets, etc., and along with software, in this case, cloud-based software that you can use to process your data. The model or the licensing model is on a pay-per-use basis, so it's very, very affordable. And basically, as I say, this is basically a low-cost, low-risk entry in terms of basically getting into the UAV surveying and mapping industry. So it's a good way to either check out different systems out there and to evaluate and analyze those systems by subscribing to them, or even just running a business where you're basically subscribing to these systems on an ongoing basis. So maybe a one-year subscription or whatever. In these cases, you're actually offered the maintenance and upgrades and improvements as part of those subscription offerings. So that's a big advantage with DG as a service. So it's worth maybe checking out if you're interested. So I just want to kind of highlight saving time and money. I mean, really that is going back to our, answering our question, why is direct georeferencing essential for profitable UAV surveying and mapping? There's a few key points that I want to make on this. So if you don't remember anything else, these are kind of some of the key points to remember. First of all, we can reduce or eliminate the need for ground control points. We can drastically reduce the time spent on post-processing the data collected, as well as we can resolve some of those inefficiencies that are inherent with RTK and PPK alone using DG. So those are a couple of key points. Also, we can reduce the image overlap. This is a biggie. So basically, the issue with a lot of small UAVs, you can fly 20, 30, 40 minutes with those small UAVs. But if you have a system where you can fly twice the area as opposed to using PPK or RTK, or you can fly the same area in half the time, that is a big savings and big value right there. and the speed up of the data processing, as I've talked about a couple of times, because we're just basically crunching numbers here. We're not doing a lot of physical interaction via mouse clicks and that kind of thing as you would with an AT solution. We can process the data much faster. So those are a couple of, or I guess 2 or 3, key reasons why direct georeferencing is important and essential for profitable UAV surveying and mapping. Now, I just want to take a look at what are some of the applications that DG supports or direct georeferencing supports best. And maybe these are some cases where basically the only solution is direct georeferencing. So let's take a look at some of these. So first of all, surveying and mapping within inaccessible areas. So this might be, say, for example, in an area where you have a landslide. Maybe prior to that landslide, you may have even had some monuments or some well surveyed in ground control points, etc. And well surveyed in ground control points. And after the landslide happened, basically all of that's gone. All of your ground control points are gone. Your monuments may be gone, but you may have a map that showed the area prior to the landslide. And what you want to do is get an update in terms of what has moved where in an accurate fashion, and then overlay that with what was there prior to the landslide. So you don't want to send somebody in there to lay down ground control points, especially not in a landslide area, because things could be shifting all the time. So it'd be very dangerous to do that, but you can still fly the entire area accurately using direct georeferencing because you don't need to have any ground control points. And even for your checkpoint, you could basically just put that on the edge of the landslide and capture the point that way. And there's other scenarios as well. There's basically working in, say, for example, mine sites where you've got a lot of heavy equipment moving around, et cetera, and you want to make sure that you're not putting in anyone in danger in terms of basically laying down ground control points if you're using AT, or even if you're using PPK for your processing. Another example of that might be a garbage dump. Again, the same kind of scenario here, where it's all about safety and security of your crew in the field, as well as saving time, but not sacrificing precision and accuracy. And I did also mention that LiDAR is really dependent upon direct georeferencing because it is really the best way to get each of those points in your LiDAR point cloud on the ground exactly where it needs to be. And so really, direct georeferencing is essential for LiDAR. And I would say certainly the larger portion of the organizations we work with, they use our direct georeferencing solutions for their LiDAR sensors and payloads. It's very, very common to see that. Another example would be corridor mapping. So mapping corridors is a little bit difficult depending on what methodology you're using to orient your data on the ground. Typically, if you're using AT, you're going to be laying down ground control points, if there's none existing there, over each of the different segments and flying those segments one at a time. That can be very time consuming and very costly. With direct georeferencing, you don't need to lay down any of those ground control points. In fact, you can fly a single strip of LiDAR mission data and get that data accurately registered on the ground to where it's supposed to be. So that is a huge game changer for corridor mapping, is using direct georeferencing with LiDAR systems. So why is direct georeferencing essential for profitable UAV surveying and mapping missions? So in summary, you can ditch the ground control points, you can reduce the overlap, you can decrease your processing time, and you can use it in those areas where other solutions are not possible. And therefore, that is why you might want to use direct georeferencing to manage profitable UAV survey and mapping projects. Okay, so next steps. Our UAV survey, basically, our technology is primarily geared towards original equipment manufacturers. So these are the UAV manufacturers, the systems integrators, or the sensor payloads. As I say, we still work with end users who are deploying systems in the field if they have the engineering experience to be able to integrate the technology into their platform. But we tend to work primarily with the OEM partners. And what we provide to those OEM partners is basically full Applanix support for payload integration. So what that means is you get access to our engineers, and our engineers have a lot of experience in terms of integrating the technology into all kinds of different types of UAV platforms, all kinds of different types of sensor payloads. So we have a lot of experience with that. We also have documented that experience in terms of evaluation kits and testing and integration manuals and these type of things. We provide to those who are potential OEM partners, we do provide an APX evaluation kit for testing purposes. And if you're interested in that, you can talk to either Peter or Naush about that. And they can provide more information on that for you. And then, as I say, the engineering support, we provide both that assistance and advice on best practices. So for example, those best practices might be on, say, for example, positioning your antenna or setting up the board on the UAV platform itself, or basically selecting a configuration to serve the market that you want to get into with respect to UAV survey and mapping. So just before we open it up to questions, I'm going to ask Peter just to make a few comments here on Australia grants and tax credits. And he can just give you a little bit of background, what's available in the Australian market. So Peter, if you're there, please go ahead.
Okay, there are different kinds of grants that are available from the state and federal governments. They are interested in companies growing and innovating, etc. And those grants can take several forms. Sometimes they're in the form of a loan, a low interest loan. Sometimes they're in the form of matching funds. If you put in a certain amount of money, they'll match those funds so you can more efficiently make your development. It could be that it's in the way of export marketing development grants. So if you're going overseas to develop your market after you've developed your product, there are incentives there. And there is a standard Australian Tax Office R&D tax deductions. Some of the grants may be directly in industry, such as agricultural or mining or defence, and others may be in the help of business insights, and you may be able to get access to a business consultant that can look into areas that you could go into that market and help you with strategy and business planning. I find the site grantguru.com.au is pretty good. You can go in there, you can put in where you are, what industry you're in, and it will then sort on current grants. And it's a good idea to check in often because grants do change. Some funds some grants use up all of their funding, and so those grants will disappear, and then other new ones will come up. And I would really recommend looking in if you're getting into that area of R&D. There's a lot of people that can help you out there to move you forward, both with advice and with physical money to do that development.
Great. Thanks, Peter. Good information. Certainly, if you're interested, take a look at that and look up the website and learn a little bit more. Okay, so and speaking of learning a little bit more, I mean, where can you go to learn more about these products? Certainly, you can go to our website, applanix.com. If you take a look in the products tab, you'll see something called DG-UAVs. We've got a lot of information there. We've also have a lot of information under our industry tab as well on the website. So you can find information there. You can also find information at the 4D Global site, 4dglobal.com.au. If you take a look at the Applanix page, a lot of good information there. And of course, if you have any inquiries, the best person to get in touch with is Peter, and his email is there, peterterrett@4dglobal.com.au. So that's where you can get some great information. I should also point out too that we've actually started a series on turning your UAV into a professional mapping solution. It's a webinar series, and we talk first about, what direct georeferencing is and why it's important to UAV surveying and mapping. There's a webinar on that. We have a separate webinar on augmentation solutions. We have a separate webinar on POSPAC. We have a separate webinar on the direct georeferencing as a service, and you'll find other webinars in there as well too. So those are really great sources of information, as well as the Planix YouTube channel. You'll find a lot of great videos there where you can learn more. And on that note, we'll open it up to questions if we have any. So now would be a good time to enter any questions that you may have. We certainly have a few minutes to take some questions. And if we, or basically, if you, as often happens with myself, I'll get off of one of these presentations. I go, oh, I wish I would have asked that question. Well, if you think of that, please just email Peter, and through Peter, we'll get you the answer to any questions that you may have if we're not able to answer them this evening, or if you think of it later on and you want to just get an answer to that question. So I'm going to ask my colleague from marketing, Cynthia, who's also on the call with us, if we have any questions tonight, or I guess this morning. It's my evening here in Ottawa, but it's your morning in Australia.
Hi, Brad. We're still waiting for a few questions to roll in, so maybe you could take this time to discuss some frequently asked questions about our products and solutions.
Sorry, to which?
To answer some frequently asked questions that you may know that people usually ask
Sure.
about or inquire about.
Yeah. Okay. So yeah, I think one of the common questions that we have is often which is the right board for the application that you're trying to use. So, and I realize that there's, in the UAV industry, there's so many different companies out there, different solutions out there, sensor payloads, cameras, LiDARs, generating point clouds through pixel matching techniques. There's a lot of information out there, and it's hard to sift through that if you're just starting out. But one of the things that we like to do at Planix is basically be a partner in terms of advising on technology. So if you're wondering where to get started, if you're wondering what board sets to use, or if you're wondering which boards match to which applications, we have a lot of information on that, and we're very happy to share that with information with you freely. And one of the things that we do for that, and we like to do for that, is that if you decide you want to implement our technology, or you decide you want to investigate becoming an OEM partner with Planix, we're very happy to set up a call, and we'll walk through everything with you in detail in terms of both how everything works, but plus in terms of integration and what it takes to get the technology deployed into your UAV platform or sensor payload. Will certainly help you with that and talk you through that whole scenario. So that's something that a lot of people are concerned about. Initially, working with an OEM board, it may be a little bit daunting, but we try to alleviate that as much as possible by providing you with those manuals and those expert help in terms of getting that all set up. So that's something that we that we offer. And if you want to learn more about our OEM program, we also have the whole program outlined on our website as well. You'll find it there. You may have to click through a few pages to get to it, but you'll find it. And we do describe what the OEM program is all about. And as part of that OEM program, we offer cost savings on acquisition of the technology, as well as access to our best engineers for getting things deployed and set up. So that's one question that I receive quite a bit. Well, I'm sure there's a lot of other questions. I guess one of the other ones is consuming POSPAC. POSPAC is available as a subscription through OEM partners. So All of our cloud-based POSPAC software is available on a subscription basis. We do offer the traditional perpetual licenses with our POSPAC software, and we are introducing term licensing with our POSPAC software. So whatever way you want to consume the software to process the data, we have lots of flexibility in terms of models or methods that you can use to work with that technology on the POSPAC side.
Thanks, Brad. We have one question here. It says, I'm currently a user of APX15 system with Regal Mini VUX 1 UAV. What help is there available to me direct from Applanix for tech support?
Well, typically with, so in that scenario, you've basically bought a system from our payload manufacturers, like Regal is, top of the line systems in terms of LiDAR. They are an Applanix OEM partner. They've integrated the technology into their systems, our DG technology into their systems, and then have deployed that and sell that technology around the world. My first recommendation would be to go back to Regal for any support questions you may have, because Regal's actually integrated the processes to collect the data with their systems and to process that. And in often cases, what they do is they take our software, say for example POSPAC, and they'll add to that through the command line interface to actually make it even more easier to process that data using their implementations and versions of POSPAC. So my first suggestion would be to go back to Regal. But I tell you, if you don't have or if you don't get a satisfactory answer, or you just want to validate something, you can always contact our tech support team, techsupport@applanix.com, and we're always happy to answer questions. But we tend to ask our users out there to go back to the manufacturer who sold them those sensor payload or the UAV platforms, because they've often implemented specialized tools. They've augmented what we have to offer and then have deployed that within their own solutions. So they're the best ones to comment on how to use their own processing solutions.
Thanks, Brad. I think that's all the questions we have so far.
Okay, well, let me just check with Peter and Naush. Peter, is there anything further that you would like to add?
Not really, but other than I'm very happy to hear from anybody that is looking at integrating Applanix into any of their payloads, either as a manufacturer of a payload or an integrator for UAVs. The nature of the Australian continent, as you mentioned, with lots of land and lots of coastline, really does lend itself to using drones and DG. And it's interesting that if you are a fairly regular user, the payback time on going direct georeferencing and then the ongoing savings after that is really an economic benefit for people who are using drones on a regular basis. And I do look forward to hearing from anyone.
Great. Thanks, Peter. And Naush, any concluding comments from you?
No, just thanks for the presentation, Brad. It was very good. And like you and Peter said, if anyone does have any follow-up questions or wants to learn more, Peter's available by email and call as well once you get in contact with him. So, we have a lot of information with Peter and on our website as well. So feel free to browse our website and learn more. And like I said, if you have any questions, Peter's available in your local time zone as well to answer any questions.
Absolutely. Thanks, Naush. And Cynthia, if we don't have any more questions, we'll just wrap it up now.
Sounds good, Brad. Thanks.
Okay. So thank you, everyone. Thank you for attending. We really appreciate you taking some time out. I do realize that often there are people who sign up and choose to view the webinar at their leisure on their own time or in a time which is convenient for them. And so we will be circulating this out to both yourselves and to those people who may not have attended this morning, but will still end up wanting to have a look at the webinar. And of course, if there's anyone you want to forward the webinar to, or to have a look at it, by all means, please pass it on. And on that note, we'll wrap everything up, and I'll ask Cynthia to close out our session for today. And again, thanks so much for attending. We do really appreciate that. So have a good day, and we'll talk to you soon, hopefully. Bye-bye.